Today's section is 2.3 on continuity. Our goal is to determine if functions are continuous at specific points and intervals. To start, we'll look at the definition of continuity. A function f is continuous at the point x equals c. So our point is our x value of whatever constant we're looking at. If these three things, the limit as x goes to c of f of x exists, if we plug c in, f of c exists, and the limit as x goes to c of our function is the value at f of c. So we are going to be looking at these three things and checking, is the function continuous? Here's some continuity properties. A constant function, f of x equals k, so if we had like y equals 5, it's continuous for all x. So if we come across a constant function, that'll be really nice to us. It'll be continuous over all of our domain. For n, a positive integer, if we have f of x is x to an n, so a power function, it's continuous for all x. So these are like x squared, x cubed. A polynomial function is continuous for all x, we know that. A rational function is continuous for all x except the values that make our denominator 0. We've talked about that before. For n, an odd positive integer greater than 1, the root, the nth root of our function, is continuous wherever f of x is continuous. And if it's an even root, then it's continuous wherever f of x is continuous and non-negative. So remember your root properties for number 5 and 6. Now, if we're trying to construct a sign chart, here are some helpful steps. First, find all partition numbers. The partition numbers are anything that make the function either discontinuous or 0. So just like we were looking up here at our properties, we are going to make sure that we find those numbers that cause our function to do something silly, like become discontinuous or go to 0. Those will be where we make partitions. And then we'll plot the numbers from step 1. So we'll put them on a number line, dividing up our line by all of our partition numbers. We'll test a value in each interval. So in between each partition we make, we're going to choose a value that's in between there and test and see, is our function positive or negative in between those numbers, in between the partitions we made. And then we'll construct a sign chart with our values from step 2 and 3 combined. Let me show you what I mean. In problems 1 through 5, using the continuity properties, determine where each of the functions are continuous. So first we're just going to take a function and say where it's continuous. Number 1, f of x equals 5x cubed minus 3x squared plus 2x minus 8. So this is a polynomial, and our properties tell us that polynomials are continuous for all x. So that one is not scary. It was a nice, easy start for us. What's number 2? X cubed plus 4x squared plus 3x minus 7 over x squared minus 9x minus 36. That's a rational function. And what does it say about rationals? It's continuous for all x except when our denominator is 0. So that's what we're going to look at, is where will what values of x will make our denominator 0. I don't know why that was hard for my brain to say, but I mean, eventually we got there. X squared minus 9x minus 36 equals 0. So what values of x will make our denominator 0? That's what we're interested in. So the first thing I'm going to do is factor. And 36, let's do 12 and 3. And if we have a negative 12 plus 3, we'll get negative 9. Now, since we're multiplying these two things, we know that one of them is going to be 0 to make the whole thing 0. So x minus 12 equals 0 means x is 12. X plus 3 equals 0 means x is negative 3. So our function is continuous for all x except x equals 12 or x equals negative 3. Okay, f of x equals 3x minus 2 over x squared plus 3. Again, we have a rational function. So we are interested in x values that make our denominator 0. So we're looking at x squared plus 3 equals 0. And x squared equals negative 3 isn't going to get us, we don't have any number that we can square and get out a negative 3. So the denominator doesn't have a value of 0, so this one is continuous for all x. No restrictions on him. F of x equals the cube root of 2x minus 5. So this is an odd positive root. And our properties tell us when it's an odd positive root, then our function is continuous for all the values where the radicand is continuous. So we're looking at 2x minus 5 specifically. So anywhere that this is continuous makes the whole thing continuous there. And 2x minus 5, well, that's a polynomial. And a polynomial is continuous for all x. So this whole function is continuous for all x. So always go back to your properties. What does the property say? Those are like our rules that we're following. F of x equals the square root of x squared minus 25. So now we have an even root. And for an even root, the function is continuous for all values of x where our radicand is continuous and non-negative. So now we're interested in x squared minus 25 being continuous. Where is it continuous? And not negative. So it has to be 0 and above. So if we solve this inequality, x squared greater than or equal to 25, x squared is going to be 5 or negative 5. You know what? I'm going to rewrite that. One other way we can write that using correct symbols, plus or minus 5. So this tells us that for all of our values between negative 5 and positive 5, our radicand would be negative. So if we're making it non-negative, it will go from negative infinity all the way up to that negative 5, and we can include the negative 5 because that will make it equal 0, and we said greater than or equal. Unioned with the positive 5 all the way up to infinity. That's where our radicand is non-negative. And you can test it out if you want to plug some values in that are in between 5 and negative 5 to see, yep, it comes out negative, so we're not interested in those ones. Okay, in problems 6 and 7, use a sign chart to solve each inequality. Express answers in inequality and interval notation. Okay, so now we're going to use that sign chart we talked about on the first page under our properties. We have 4x squared minus 29x plus 7 is less than 0. So first step, we need to find our partition numbers. So is there anywhere on 4x squared minus 29x plus 7 that is discontinuous? And no, polynomials are continuous for all values of x. Is there a value or values of x that make this 0? Yes, there are, and those are going to be where we partition. So let's find our partition numbers. We will take our 4x squared minus 29x plus 7 and find out what values of x make it 0. So let's factor 4x and x, 7 and 1, but we need 7 times 4 to make 28, 29, minus. Think so. 7 minus, positive 7, negative 29. Yep, we got it. Okay. So what are our values? 4x minus 1 equals 0. 4x equals 1. X equals 1/4. And x minus 7 equals 0. X equals 7. So our partition numbers are 1/4 and 7. So we're going to make our number line and break it into 3 parts based off of these partitions. So we'll have 7 and 1/4. And it's not drawn to scale. But we've broken up, we have our partitions, and now we're going to test these values in the partitions to see what's going on in our function, okay? So first we'll choose a value on this side. So a value less than 1/4. I always choose easy numbers to work with, so I'm going to choose 0. So I'm going to put f of 0. I'm going to plug in a 0 and see what happens. This is going to give us f of 0 is 4, plug in 0 squared. minus 29, plug in 0, plus 7. So that's a 0, it equals 7. So this is positive. I'm going to put a positive sign here. Then we've got in between 1/4 and 7. We pick a value. I'm going to put 1, because that's a nice, easy number to work with, and it falls in between 1/4 and 7. So f of 1, 4 times 1 squared minus 29 times 1 plus 7. So we've got 4 minus 29 plus 7, negative 18. So this comes out to be a negative. And then we'll do a number greater than 7. Let's just go one more and do 8. So f of 8, 4 times 8 squared minus 29 times 8 plus 7. We've got 256 minus 232 plus 7, 31. So we've got positive. So we found the partition numbers. That's where our function goes to 0. And what's happening on either side of each of these zeros, we have a positive part of our function, then it hits 0 and goes negative, and then it hits 0 again and goes positive. The question was, we want our inequality and interval notation to solve for x squared minus 29x plus 7 is less than 0. Okay, now it's really easy to see where our function is less than 0 because we've broken it down and we can see right there. It's negative, that's less than 0. So we'll write inequality notation between 1/4, it's greater than that, but it's less than 7. We can't put greater than or equal to because at 1/4 and at 7, it's 0. We only want the values where it's negative. Interval notation will be from 1/4 to 7, using parentheses because we're not including them. So that sign chart really made it super easy to see where our function is positive and negative. Let's do another, just so that way we can see it again, feel a little more comfortable. X cubed plus 3x squared over x plus 5 is greater than 0. So let's first find our partition numbers. First, I'm gonna look at when x plus 5 is 0. That's when our denominator is 0, so it's discontinuous, which gives us x equals negative 5. Now I want where the numerator is 0 because that makes my whole function 0. X cubed plus 3x squared. So let's factor x squared, x plus 3. So x squared equals 0, x equals 0, and x plus 3 equals 0, negative 3. Okay, so we have our partition numbers. We'll do 0. Oh, they're all negative. Okay, let me redo this. 0, negative 3, negative 5. And now we're going to test values on either side of these partitions. Remember, these partitions represent where we found a zero or a discontinuity. So we are interested in what's happening on either side of these things. So a number less than -5, let's do -6. If we plug in a -6, we'll get -6 cubed plus 3 times -6 squared over -6 plus 5. Numerator -108, denominator -1. So it comes out to 108. This is a positive. Now in between -3 and -5, we'll do -4. So we've got -4 cubed plus 3 times -4 squared over -4 plus 5. So -16 over 1. So -16, so this is a negative. In between -3 and 0, I'm going to go with -1. So f of -1, -1 cubed plus 3 times -1 squared over -1 plus 5. So 2 over 4. 1/2, so positive. And then greater than 0, let's just do 1. F of 1 will be 1 cubed plus 3 times 1 squared over 1 minus 5. No, 1 plus 5, sorry. 4 over 6, so 2/3. Positive. Okay, now we were looking for when our function is greater than 0. When is it greater than 0? Here, here, here. So our solution will be from -infinity to -5, not including, and then from -3 to 0, not including, and then from 0 to infinity. Okay. And this last part probably feels like we didn't really need to do that, but we do because we can't include 0. Remember, we're looking at where is it strictly positive, and at 0, it makes the whole function 0. So we do need to put them in their own little parentheses, so that way we're not including that 0.